The following graph represents the distance, d, in meters, of a person from home at time t in seconds. For a distance versus time graph, the slope corresponds to the speed. Be aware, however, that for speed, we only consider the magnitude of the slope. The sign only gives information about the direction of motion. We use the formula for slope as m equals rise over run, where the rise is the change in the vertical component, the run is the change in the horizontal component. A positive slope corresponds to forward motion. A negative slope corresponds to backwards motion. Recall that a positive slope is one that slopes upwards as moving towards the right. A negative slope slopes downwards, moving towards the right. A slope of 0, which corresponds to a horizontal segment, means that the object is not moving. For question A, what is the domain and range of the relation? Recall that the domain corresponds to the possible values for the independent variable, in this case, the time. Note that the time cannot be negative, so we have 0 less than or equal to t. And note also that the maximum time recorded on the graph is 20 seconds. This means we have 0 less than or equal to t, less than or equal to 20. We also have to include t is an element of the set of real numbers, since we can have any value of t between 0 and 20. For the range, here we have to look at the dependent variable and look at its possible values. In this case, the distance. Note that the minimum distance in this case is 2 meters. The maximum distance is 12 meters. The range then, 2 less than or equal to d, less than or equal to 12. And again, d has to be an element of the set of real numbers. Question B, what is happening between 4 and 6 seconds? Between 4 and 6 seconds, note that the graph is a horizontal segment. If the graph is horizontal, then the slope is 0, and this means that the object simply is not moving. Note that the distance is unchanged. This means that the rise is equal to 0, and so the slope is equal to 0. The person then is not moving during this time interval. For C, between what times did the person walk the fastest and the slowest, but still moving? Here we need to find the slopes for all of the slanted intervals. For interval A, 0 to 4 seconds, the slope is equal to the change in the y-coordinate, or in this case, the distance, 12 minus 6. Note that for segment A, the maximum distance is 12, and the distance at the beginning is 6. We then divide this by the change in the time, or the horizontal change. Note that this is 4 for the maximum time of this interval, and 0 for the initial time in this interval. This gives a result of 6 over 4, or 1.5 meters per second. Note that the positive in this case means that the object is moving forward during this time interval. For segment B, this occurs between 6 and 14 seconds. Again, we figure out the slope as the change in the distance, this time 6 minus 12, divided by the change in the time, 14 minus 6. This gives a result of negative 6 over 8, or negative 0.75. Note the negative sign here means that during this interval, the object is moving backwards. For segment C, between 16 and 18 seconds, the slope is equal to the change in the distance, 2 minus 6, divided by the change in the time, 18 minus 16. This gives us negative 4 over 2, or negative 2 meters per second. And for interval D, 18 to 20 seconds, again the slope, the change in the distance, 8 minus 2, divided by the change in time, 20 minus 18. This gives 6 over 2, or 3 meters per second. Note here that the fastest interval corresponds to interval D. 3 is the highest magnitude. The slowest corresponds to interval B. That corresponds to the lowest magnitude of the slopes. Question D. Between what times did the person walk away from home and towards home? For away from home, this corresponds to segments where the slope is positive. This corresponds to segment A between 0 and 4 seconds and D between 18 and 20 seconds. Towards home, this corresponds to a negative slope. Segment B between 6 and 14 seconds and C between 16 and 18 seconds.